All right. This is assignment 11, office hours. This is the front side. So I already did the back side. It's the front side. These are no calculator problems. This is an extra credit review worksheet. No calculator problems will most likely be part 2 of the second day of the test. No calculator, and this is going to be the bar test that is definitely tough to finish in the time if you're not totally ready for all these problems. So part of it's going to be test taking strategy. If you run into a problem you don't know how to do or you're having trouble with, you should move on and do the problems you can do first while you have lots of time, and then come back to the tough ones. And better yet, make sure you're ready for all of them so that you have less of those kind of decisions to make. These are the answers. Should have checked already. So we're just doing this side. So this is going to involve solving trig equations, solving trig inequalities, evaluating trig for special angles without a calculator, special right triangles, graphing trig, all without a calculator. So try these problems. So the first problems were just finding these answers. So hopefully you've memorized the basic angles and their corresponding values for degrees and radians. After this chapter, it's always going to be radians, so got to get the hang of radians sooner than later. Alpha. So this would be 180. This is in quadrant 3. This is alpha of 60 degrees, quadrant 3. If you have to, you could draw a picture, trying to figure out where it's at. 90, 180. That'd be 270, so it's short of that, and this is your alpha. That's quadrant 3. But you shouldn't have to draw triangles and things like that. You should have sine of 60 memorized. 0, 30, 45, 60, 0, 1 half, root 2 over 2, root 3 over 2. So I memorized the angles and the values separate. Okay, that makes it really helpful for radians. Quadrant 3, it should be negative, though. That's it. That's your answer. Okay. Secant is 1 over cosine. Okay. And alpha equals, so pi is half circle, so alpha is pi over 4. We're in quadrant 3, right? 4 pi over 4 would be a half circle, so gives you an extra pi over 4 into quadrant 3. Sine and cosine, pi over 4 is root 2 over 2. In quadrant 3, cosine is negative. It's going to be negative 2 over root 2. It's going to be negative 2 root 2 over 2. It's going to be negative root 2. There you go. Tangent 13 pi over 6. So tangents can be sine over cosine. I don't memorize values for tangent. Now, reference angle is pi over 6. 12 pi over 6 is a full circle. So now we're starting into a new circle, pi over 6, quadrant 1. 0, pi over 6, pi over 4, pi over 3, pi over 2 are those common angles in quadrant 1. So this is that first angle, 0. For sine, it's 1 half. For cosine, it's root 3 over 2. And they're both positive. It's going to be 1 over root 3. So it's going to be root 3 over 3. There we go. So this should be quick. Solving trig equations, we're going to be using the same ideas but backwards. So you want to isolate the trig. So get the cosine by itself, subtract root 3, divide by 2, order of operations in reverse. You want to say, well, what's alpha? Ignore the negative. 1 just cosine equal root 3 over 2. It's that first angle. I'm doing degrees here, so it's going to be 30 degrees. What quadrants is cosine negative? 2 and 3. So usually multiple places we get answers. So x equals, quadrant 2 would be 180 minus 30 would be 150 plus 360k. Quadrant 3 would be 180 plus alpha, 210 plus 360k. And so we just want the answers from 0 to 360. So it's going to be 150 degrees and 210 degrees. Should write the degree symbol. Otherwise, no unit on angles usually indicates radians, which is what we're not doing right here. Okay, tangent. Tangent is sine over cosine. So you go, well, sine equals root 3, cosine equals 3. I don't know those. Okay, well, consider that either 1, they're over 2. That doesn't quite help. The other thing to consider is that maybe it's a rationalized answer, and that root 3 over 3 is actually the same as 1 over root 3. And then we throw in the halves. That looks a little more familiar. So, what's the reference angle? It should be the same for both of them. When does sine equal 1/2, cosine equal root 3 over 2? Ignore any negatives or anything, which aren't there. That's that first angle, 30 degrees. What quadrant could this be in? Quadrant 1, they're both positive, but also quadrant 3, they're both negative, which gives you a positive. Quadrant 2 would give you a negative tangent answer. Quadrant 4 would give you a negative tangent answer. Now, the thing about tangent is that its period is 180 degrees. So these are going to be exactly 180 degrees apart anyways. So you could just go with quadrant 1 answer, 30 degrees plus 180K. And then you don't have to deal with two different situations. Now, if you uncheck, you could do quadrant 3, which would be 180 plus 30 be 210 plus 360K, and 30 plus 360K is going to give you the same answers that this does. So I would try and take advantage of that. Tangent and cotangent have period on 180. So cuts down on the work quite a bit. So we want all the answers between 0 and 360. So 15, 105, 195, 285, 375 would be the next one. Too much. 4 answers. Now, it's kind of what we expect. You usually get 2 answers, but the extra 2 on the inside cuts the period in half, doubles our answers. Okay. Number 6. It's the inequality. So we're going to actually treat it like an equation first, and then create a line check to figure out the less than greater than intervals. Put it all on one side equals 0, already true. Factor it if you have to. So we're going to GCF, it's going to be sine 2x. 0 product property says you can set each of these equals 0, as long as everything actually equals 0. So at this point, I'm ignoring the inequality symbol because I'm just trying to find the zeros. If you said, oh, this is greater than and this is greater than, that's actually not right. Because it could both be less than, and then this would be true. A negative times a negative is a positive. So we don't go there. When does sine equal 0? At 0 plus 180K. And when does sine equal 1/2? That's 30 degrees. Quadrants 3 and 4. So it's going to be 2x equals, quadrant 3 be 210 plus 360K. And quadrant 4 is going to be 330 plus 360K. So then we're going to solve 2. Now, watch out for the bounces. So if you got sine or cosine equal plus or minus 1, then you got to keep track of those. Not an issue this time. But we're going to get lots of zeros, I think. So I'm very methodical with these. I always show all this work. But I do pretty well because I'm just automatic. So 0, 90, 180, 270, 360, 105, 285, 165, 345. It's quite a bit. Okay, so I'm going to do one line check. I'm going to go 0. Now, these are all solid dots. 0, 90 is the next one. I don't really care if they're spaced out correctly. I just want them in order left to right. 105 should come next. 165. So I like to cross these off because it's easy to miss one. And if you miss one, then you'll realize it at some point if you're crossing these off. A lot of times I'll put the 360 boundary on the right hand side right away, but there's so many here that I was just worried I was going to run out of room or whatever. Okay, so I put these little brackets to indicate, oh, we're only interested in 0 to 360. So I'm going to stop looking for roots because these roots go on forever. There's infinite. Now we're going to test a value. Tell me what you're testing. I like to test 0 for trig, but I can't because there's a root there. But what if we plug in is going to get doubled? So 90 is a good one because sine of 90 is 1. So, but if we put 45 in, then we're going to get sines of 90, right? So that's 1, 2, plus 1 is 3 is true. So 45 is true, false, false, true, false, true, false, true, false, true. Darken in the trues. So you get a picture of your answers. Now you got to write an interval notation. So brackets, 0 degrees 90, 105 to 165, 180 to 270, 285 to 345. And then don't forget, 365 is all on its own for us. It is part of an interval, but we're only interested up to and including 360, which is just the edge of it. If we're an open dot, we wouldn't put it. So there you go. Just got to be, be careful in this. It's real easy to make mistakes, lose things, forget things. So just be very, very purposeful here. Okay, now we got to move everything one side equals 0 first. So minus cosine 2x minus 1 less than 0. This is like a quadratic trinomial kind of pattern here, but with trig mixed in. So we're going to unfoil it. Definitely 1 and 1. One of them's negative, one's positive. We want to get negative 1 in the middle, so this one's got to be negative and this one's positive. So then cosine 2x equals negative 1/2. And cosine 2x equals 1. And you should be like, oh no, sine of cosine equals plus minus 1. These roots are going to be places where the graph bounces off the graph. So it's going to stay true on both sides. It's like a double root. Alpha, when does cosine equal 1/2? 1, root 3 of 2, root 2 of 2, 1/2. 0, 30, 45, 60 degrees. Quadrants, 2 and 3 is when it's negative. So 2x equals, quadrant 2 is going to be 180 minus alpha, 120, plus 360k. And then quadrant 3 is going to be 180 plus alpha, 240, plus 360k. And then this one is going to be 2x equals, cosine equals 1 at 0, plus 360k. These guys, got to keep track of them. Divide by 2, 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 divide by 2. X equals 60 degrees plus 180k. X equals 120 plus 180k. X equals 0 plus 180k. So X equals 60, 240, 120, 300, 0, 180, 360. Now these guys are those bounces. Okay, so now we're going to do a line check. Trying to fit all this in. 0, these are going to be open dots. 0, 60, 120, 180, 240, 360 or 300 and 360. Okay. But 0, 180, and 360, those bounces. So we're going to test. Can't test 0, but whatever plug in is going to get doubled. So let's go with 45. Cosine of 90 is 0, so that's convenient. 0 is less than 1. True. So this one's true, stays true, false. True, stays true, false. True, stays true. So I'm looking to see if you caught it even right at the boundaries. Sometimes people forget and they get lucky. Now on this one, clearly there's one in the middle, so I'm going to catch it pretty quickly if you didn't note that bounce issue. But the answer is going to be 0 to 60, parentheses, 120 to 180. Got to break it up 180. If it were solid dot, you wouldn't. You just say 120 to 240. But it's open dot, so you got to break it up. There you go. So those are definitely some challenging problems. Just got to be careful on those. Share your work too. I mean, share your work so that hopefully you make less mistakes. Share your work so I can help give you partial credit when you make mistakes. I can figure out, oh, that's what they did quickly. If I can figure it out, you make it hard, I'm going to give up. I'm just assume it's all wrong. So help me figure out what you're doing right. Special right triangles. So this is kind of like some of the problems we're doing in the calculator on, but these are going to result in all nice answers. AB equals BC. So it's a sausage triangle, which also means it has two equal angles, which means it got to be 45. It's the only way you can have an isosceles right triangle. 45, 45, 90. CAD is 15, which means this is 60, which means this is 30. You got a big 30, 60, 90. The 45, 45, 90 is inside the AC is 12. So I personally would just try and find all the missing information. Now, I already found all the missing angles, so got that done. Now, I'm going to work this piece right here is part of, there's two special triangles. It's part of the 45, 45, 90. So you want to work off that to find these sides. Now, usually it's like S root 2, right? So S equals 12 over root 2, which is 12 root 2 over 2, which is 6 root 2. So this is also 6 root 2. So then you can use this side because this side isn't part of the 30, 60, 90, but this is. That's got to be the short leg. So the hypotenuse has got to be double that, 12 root 2. And then the long leg, this whole thing right here, is a short leg times root 3. So it's going to be 6 root 6. Which means this chunk right here, which is something you actually got to find, is going to be the whole thing 6 root 6 minus 6 root 2. So this is going to be 6 root 6 minus 6 root 2. And you can't simplify that. So we got that. 6 root 6 minus 6 root 2. That's as good as you can write that answer. Okay. Area of triangle ACD is this skinny triangle that gets created. And let's just do 1/2 base times height. I think we got everything. The base is 6 root 6 minus 6 root 2. The height is 6 root 2. So let's just simplify that. You can bring this in if you want. Get 3 root 6 minus 3 root 2. And then do the 6 root 2 or whatever. You could do this in other order. So this is going to be 18 root 12 minus 18 root 4. We could simplify this. We could take a 4 out. Square root of 4 is 2, so it's going to be 36 root 3 minus square root of 4 is 2. So 36 root 3 minus 36 is your final simplified answer. There you go. Show your work, find all the missing stuff, then you can answer the questions. Now for the graphing ones, I guess you know what kind of work I'm looking for. I want one complete period, not more, not less. I want the maxes, mins indicated, labeled. Horizontal lines, I want the period and radians and degrees. And if possible, if convenient enough, I'd like it to start at the origin 0, 0. So we're going to start with 2 pi, 360 degrees, cut in half, cut in half, cut in half, mark the amplitude. Okay, so sine starts at 0, 1, 0, -1, 0. So I need to see these dots. It's called the parent function, light dash line. This is the kind of work I need to see. Then we're going to work from the inside out. We're going to divide by 2. So the period is now pi, 180 degrees. Now the negative flips it over here. So you could kind of show that. But then I want you to bring it back in here. So what's going to happen is it's going to have the effect of looking like it flipped it upside down, which is not generally that effect for other functions. So it's the upside down one. Then you can multiply by 2. And that multiplies all the values by 2. So it's this. You can multiply by the negative on the outside, which flips it upside down. So this is going to go up here. This is going to go down here. And so we're going to make it solid. So that's one period. Mark off the max and the min. They should be labeled. Should have horizontal lines. Just making sure. Your period should be here, radians and degrees. There you go. Okay, next one. Mark off the period. 2 pi 360. Cut in half. Cut the halves in half. Get the quarters. Quadrants. -1 to 1. Cosine starts at 0, at 1, 0, -1, 0, 1. Light dash line. That's the parent function. That's cosine. 2 divides the period by 2. So the period is now pi, 180 degrees. Need both of those. The 3 should come next. That multiplies all the y values by 3. And then the -1 moves everything down 1. So all these important dots should get moved down 1. Down 1. Picture's getting a little busy. So something like that. Then lastly, the absolute values around everything else. It flips all the negative stuff up. So this part of the graph is going to stay there. This part of the graph is going to stay here because those are positive. But the negative parts, -4 has got to go all the way up here to +4. -1's go up to +1. So transfer all the dots first. This part of the graph looks normal. And then it goes in, like if you were to keep drawing, it start to curve up until it hits that piece there. You get that sharp change in concavity. And so the max is at 4, the min is at 0, period is labeled. That's what I'm looking for. Okay, next one is the sine curve. 2 pi, 360 degrees, cut in half, cut the halves in half, get the quadrants. Amplitude initially is -1 to 1, sine is 0, 1, 0, -1, 0. Light dash line. Now in here, we need to factor a 1/2 out, and we get x minus 3 pi over 2. So when you divide, you're actually multiplying by the reciprocal. So if I divide a 1/2 out, I'm actually multiplying by 2. And then that gives me 3 pi over 2. So the period gets divided by 1/2, which gives you 4 pi and 720 degrees. The minus 3 pi over 2 shifts everything to the right 3 pi over 2. Now, if this works out nice, let's go ahead and go with it. Otherwise, I'm fine with you working just from where the shift starts. So this is 4 pi. that means this is 2 pi, this is 1 pi, 3 pi over 2 is 1.5. So that moves everything over 1.5 of my marks. So I put that one in the wrong spot. So this is going to go over. This goes over 1.5. 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 So that's a new graph. Now, I'm okay with you because it's not great. You could just go ahead and make that your graph. Otherwise, you could bring it back. But you know you're going to get a dip here, and then the next one's going to be here. And so it's kind of at a weird place to cut it off at 0. I mean, if it ended right at peak or valley or right at x-intercept, then great. This one doesn't quite work. So I'm okay with either of those. Now the 2 multiplies everything by 2. I'm just going to go with the shifted graph first, and then I'll show you if you really want. So that's, I'm just going to make mine over here. Okay. The period's still 4 pi and 720, but it's just shifted. This isn't 4 pi 720, but the period is 4 pi 720 from start to beginning. The -1 shifts everything down 1. So your final graph could be like that. So I'm okay with that. Max is 1, min is -3. Okay, so that's good. Or if you wanted, you could bring this back over here. You just got to be careful. It's a little harder to, I mean, you could stop it at 0, but it's like right in the middle. But then you would want to stop this one like at the original line or something. I think I messed something up. You would be down here. Should look like wherever you start it and stop it, like they would meet up. So, but I'm okay with that being your graph. Just start at the shift at the 3 pi over 2. Okay, so that's what we're looking for. And a few more problems. It's gonna be 2-sided at least. So this is an extra credit review, some extra help. Okay.